Maybe for people that aren't super knowledgeable about quantum physics and stuff like that, I mean, what does quantum actually mean? The term gets thrown around a lot in marketing speak and, new age gurus and things like that. So when we're talking about quantum anything, quantum supremacy, quantum mechanics, quantum entanglement, what does that mean?
It's a good question, and it's one of these words that acquires its meaning by being used, in a sense. The original kind of etymology of the term is the idea of discreteness. So the idea that nature is particulate, it's not a continuous fluid, it's actually can be broken down into little particles, and moreover that the particles have properties like energy or momentum that are discrete in their values. They can't take on any values. It's more like a ladder of values. But that original etymology, we're so beyond that now in the understanding of the world. For a long time, I would then default to saying, well, quantum physics is the physics of the micro world. It's the physics of the atoms, the electrons, photons, particles. But I can't do that either, because one realization, really from early on, but more reinforced of late, is that quantum physics applies to everything in the world, including us. And that's kind of one of the mysterious or unresolved puzzles of quantum theory, is how it can apply to us when we seem so unquantum in our nature. So some aspects of the quantum realm that came from the particle, the atomic level, are things like wave behavior, that particles had this kind of odd, particles and us. So when I use the word particle from now on, there should be an us. In the,
well, right? we're essentially a collection of particles, right? I mean,
we are, but moreover, we can be taken in our entirety. Our entire body could, in principle, be considered a particle for the purposes of the analysis. So it's not just that we consist of particles, it's that also at the level of the human or of the dust grain or the moon or any objects, you can treat them for some purposes as a single entity.
Okay.
So I can talk about myself. And this is like when you go back to the Schrodinger cat. Maybe we should start with the Schrodinger cat, because I think that's a very illuminating experiment. And the whole purpose of which, so Schrodinger developed that idea in 1935, and the idea was precisely to connect it wasn't to make cats into this kind of weird icon of science. It was to connect what's happening at the atomic level with what's happening at the macro level, and actually that there would be a connection, that if a particle can be put into this weird state of ambiguity, this is one of the features of quantum physics, weird and state that seems to us ambiguous, between saying it's decayed or not decayed, or it's here or there, or it's up and down. It depends. There's different things you can say it's X and Y, and the X's and the Y's can vary.
So for people that are listening, the Schrodinger's cat, there were no actual cats involved. It's a thought experiment where this cat is put into a box, right? And there's this sort of mechanism on the outside of the box that is influenced by particles, and if the particles hit this detector in a certain way, it will release a gas and kill the cat. And if it doesn't hit it in a certain way, then it doesn't, and the cat stays alive, right? So
that the point being that the atom in this case is in some kind of ambiguous condition. And we can parse what that means, because that's actually interesting in its own right. But just take this ambiguity. It's ambivalent. It could either have decayed or not decayed at any instant. So it's 12 o'clock, it could have decayed or not decayed. It's 1 o'clock, could have decayed or not decayed. So we don't know what state at any given time. And then that ambivalence is transmitted to the cat. And the original experiment, it was through this kind of poison gas, but it can be done in other ways as well that are not so morbid.
Yeah.
But the point is that the cat then enters a state of ambivalence, in this case, between being alive and dead. And you wonder, well, first of all, how can a cat be alive and dead, or in an uncertain condition of being alive or dead?
Yeah.
Second, that when you open the box, you look in, you see a cat alive or dead.
Right.
So not only is it ambivalent, which is already bad enough, but its ambivalence is never directly observed. And this is a very peculiar feature of the quantum world, that it seems to work on two levels. There's this kind of base fundamental level where there's ambivalence and weird effects. And then there's the higher level in which we operate, where we don't see those. Mm-hmm. And the connection between them has never been clear. This is literally a century after Einstein started to develop the theory, and others came in, that we still don't know. And the same kind of ambivalence, this kind of two-level description is a problem with waves and particles. You sometimes hear, is it a wave or is it a particle? The wave is basically the lower level, and the particle is the higher level. We don't see these waves, these putative waves in nature. We only see particles, but they behave like there's waves.
Yeah.
So why? And this kind of goes under the rubric of what's called the measurement problem. And you could probably argue that it's the number one unresolved problem in physics.